I'm going to write out the general form that we talked about yesterday. And then we'll figure out what values go into each of those variables. So we have C, we have A, we have B, we have D.
Is that a Y?
Y. Alright, so maybe let's just refresh without even looking at the graph, maybe what each of the ones. Alright, can you maybe tell me what the A stands for? Or what that value is? Emily? Amplitude. Good. Amplitude is the space between your sinusoidal axis and the peak, which is the same as between your axis and the lower bound. What about D? Something displacement. What was the first? Phase. Phase. Good. Phase displacement. That's the same thing like in your general form for a bunch of different functions that we've used. It's the same thing as H. It moves your graph left and right. They just call it phase displacement because a lot of times we're talking about some kind of motion happening over time, and whenever something's moved or started in a different place, they call it its displacement. That was the original starting point. Alright, so phase displacement. The B. Now the B value is not the, what is the B value connected with? Starts with P.
Period.
Period. Good. Period. How long the cycle takes to complete itself. That value is not our period, but we use it to find our period. The reciprocal of that times 360, which represents one full rotation, is what our period actually is. And then the Z is our sinusoidal axis. That's how much our graph moved up or down. Okay? So like when we did the Ferris wheel, the chair couldn't actually hit the ground. Like there had to be some clearance for, your feet as you're going. And so the whole circle had been shifted up a little bit so that you didn't actually hit the ground. So that's how much our graph has shifted up. Alright, so let's try to figure out at least the easy ones here. What number can I put in for C? 56 is my upper bound, right?
Yeah.
Negative 38 is my lower bound. The sinusoidal axis is my C, and it is directly in between. How do I find? I find the average. Good. So, to find the sinusoidal axis, we're going to add the upper and lower bounds. So 56 plus negative 38 and divide by 2. Because you're finding the middle. The sinusoidal axis is always in the middle between the upper bound and lower bound. What is that value? 9. Okay, so that's going to be my C. So maybe up here, I'll start writing in what I find. Okay. The next natural thing, and I'm kind of going in the same order that I would go in if I was graphing this by hand, if I was working backwards from a function. You always start with the sinusoidal axis, and then you graph your upper and lower bound, and you find your upper and lower bound by using your amplitude. So we're going to find our amplitude next. The amplitude is the space between your upper and your sinusoidal axis. So if this is 9, how do I find the space between 56 and 9? Subtract them. Okay, so what's 56 minus 9?
7.
Yes. Okay, so amplitude. We're going to take 56 and subtract 9 to get, what did you say, 37? Or 47? 47. Okay, so that's going to be my amplitude. We're using cosine as my parent function, so that stays cosine. Okay. Then the next thing we usually do if we're graphing from an equation is we use the period to start marking off our values. So that's the next thing we're going to find here, because we find the period, and then we use the period to find our B value. The period is how long it takes to go peak to peak, or how long it takes to complete one full rotation before the pattern starts repeating itself. So how much space is there between 3 and 23? 20. Okay. So your period
is 20 degrees. That is not my B value. Okay. To find the period, let's see if I can pull it from my other sheets. Or does somebody have their notes from yesterday? How did I tell you to find the period yesterday? 1 over B times 360. So we just reversed the process. Instead of taking 1 over B and multiplying by 360, we take 360 and divide it by the period. So you do the opposite. So 18. The 360 represents 1 full rotation. So we're seeing, okay, how much has my 1 full rotation shrunk? And we get 18. Okay. So 18 is my B value. Technically, you could think of that as there's 18 cycles in 360 degrees, if that makes sense. All right, so the last thing that we have to find in order to write the equation, which was our goal here, is we have to find the phase displacement. Now, cosine function, the regular cosine function starts at a peak on the y-axis. So if you shift left or right, you're looking at where that peak is now. Where is that peak, the first one? 3. Could I also write it from 23? Because if could have this been the starting peak and it just shifted over that many units? Yeah. So we can really use any peak here that we need to. So I'm going to use 3 because that's probably the easiest one to identify because it's the first one. And to show that it shifted over 3 degrees, we put theta minus 3. What if I shifted to the left 3? It'd be plus 3. And then we're done. So you start with the same process. You go sinusoidal axis, amplitude, find your period, find your B value, and then see how much you shifted over. Okay. Forgot what the 4 type problem was. All right. We're going to do one graphing here like we did yesterday. So instead of working backwards from a graph to find the equation, we're going to take an equation and graph from that equation. I'm going to change something up on you here. Let's go 5 minus 2 sine of 4 theta plus 10. Okay, so we're going to graph this function. Now, before we get too much into this, I haven't talked yet about when there's a negative amplitude. Amplitude technically can't be negative because amplitude is the space between your sinusoidal axis and the peak. So technically that's a space, a distance, it has to always be positive. So when there's a negative like this, what it does is the same thing it does when you have, like in algebra 2, when we had a quadratic with a negative a value. What happens with a quadratic when you have a negative a value? It goes from this to this. Flips the function. So that's exactly what that's going to do to that sine function. A regular sine function starts at the sinusoidal axis and curves like that. So then, when you flip it, it'll go down first and then up. It just like completely shifts it. Flip-flop. Okay? So when you see a negative amplitude, that's what it's doing, is it's flipping your graph. With cosine, regular cosine function starts at a peak and goes like this. So when you flip it, if we had a negative cosine function, then it would start at the valley and look like that. It just completely flips it around the exact same. Okay, so our graph is going to look a little bit different here because of that negative, but we still have to find all the main components. So when you're graphing by hand, my first suggestion is at least look and see what your phase displacement is. Your phase displacement is going to shift your whole graph over 10 units to the
Right.
left. Because it's theta plus 10, so you do the opposite. So we're going to go to the left 10. And my sinusoidal axis is +5. My amplitude is not huge. Just when you draw in your lines here, you want to leave a little space because you're going to have to shift over 10 units. So don't just always draw your lines the same. At least give yourself enough space to draw in some tick marks. All right, let's start with your sinusoidal axis. We're going to go up 5. When you're drawing your sinusoidal axis, it's a dashed line. Because it's not actually part of your graph, we're just using it as a guide. The next step after you drawing your sinusoidal axis is to use your amplitude to drawing your upper and lower bounds. What's your amplitude here? Careful. What's your amplitude? 2. Okay. So our upper bound is going to be 2 units above the sinusoidal axis. Your lower bound is going to be 2 units below. So we go up 2, draw another dashed line in, down 2, draw another dashed line in. Kind of looks like elementary school when you have to write your letters. Alright, that's our setup. Now we have to use the period and the phase displacement to start like drawing in some tick marks so we can actually get some points on the paper. And I usually start by finding my starting place and my ending place using my period. So the B value is not my period, but I use it to find my period. To find a period, you take that B value, flip it, and multiply by 360. Now, if we were graphing stuff with radians, you'd multiply by 2 pi, which eventually we'll get to radians, but degrees are a little bit nicer to work with at first. So we have 1/4 times 360. What is 1/4 of 360? 90. Okay, so my period is going to be 90 degrees. Now, where do I make my first tick mark? At what x value? -10. Good. So, phase displacement, I'm going to sketch out, or at least write -10 here. -10 degrees. There's -10. I'm going to go, that's 1, and then I need 8 over here, right? 1, 2, 3, 4. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, wait a second. Yeah, but that's 80 degrees. Because the whole space, because your period is 90, so your space between your starting point, which is your phase displacement, and your ending point has to be 90. So I just count out 90. Everybody okay with that? Okay. Now notice I'm putting my tick marks on the x-axis or on the theta axis, not up here where my graph's going to go. Make sure your tick marks are labeled on the actual axis. Now, we can put a point where we're starting, because I know the function. The function is sine, and sine starts on the sinusoidal axis. So at -10, I'm going to put a point on my sinusoidal axis, and at 80, I'm going to put a point on the sinusoidal axis, because it has to start and stop at the same place, because the pattern is going to start repeating. Now we go and make the middle tick mark. I think I call them your turning points. This is where the graph, if we were to graph this sine function has a negative amplitude, which means it's not going to start and go up, it's going to start and go down. So you're going to curve, meet the sinusoidal axis again, curve, hit the upper bound, like this, hit the upper bound, and then meet back to the sinusoidal axis. So the 3 other important points in your graph are the place where it's going to connect with the bottom boundary, lower boundary, where it's going to connect to the sinusoidal axis, and then where it's going to connect with the upper bound. Okay, so we have 3 more tick marks we have to find. Where it connects to the sinusoidal axis again is going to be directly in between -10 and 80. So we find the average. -10 plus 80 gives me 70. 70 divided by 2 gives me 35. So we find the middle by finding the average. That's going to be my sinusoidal axis point. With cosine, it'd be peak, peak, and then the middle point would be your valley. So you have to keep those shapes in mind. Now we have to find the place where it connects to the lower bound, which is going to be halfway in between -10 and 35. -10 plus 35 is 25. 25. You gotta take the negatives into account. So 25 divided by 2 gets me 12.5. So then you mark that. Okay, so we mark the tick mark, 12.5, and then that's going to be the lower bound, right? Because you have negative amplitude, so it's going to go down first and then go up. And then we find the halfway point between 35 and 80. 35 plus 80 is 115. 115 divided by 2 is 115 divided by 2? I hear some guessing, but let's be more definite. 57.5. Good. 30, 40, 57.5 is about right there-ish. And that is my upper bound. Notice the only tick marks you have to label are the important ones. The beginning, ending, and then the turning point. And then once you get those values in, then you can connect. Whoa. Mine's really stretched out, so it's going to look really sloppy. But there's your sine function. Now, if I wanted, I could graph more than one cycle. This is just one cycle. Sometimes I ask you to graph 2. And then to do that, you would just have to take 80 and use that as your starting point and go out another 90 degrees and make new tick marks. Okay. Before we start practicing some of these on our own, do you have any questions? None? Yeah. Any questions on this? Okay. Go to iTunes U and look for the document that says G1 Practice. You're actually going to need to come back and get a whiteboard, a marker, and a rag. But that G1 Practice will have problems you can look at. And I'll tell you what problems I want you to do up here on the screen. Okay, you're coming back here to get a whiteboard, a marker, and a rag. And you're looking for your G1 Practice on iTunes. I should have more people moving. Okay, whiteboard, marker, and rag. And then looking for your G1 Practice on iTunes U. G1 Practice problem.
you're working on your